June 19, 1966. Dawn breaks over Leal. 3 Ford GT40 streak across the line, 1-2-3. A crushing, humiliating defeat for Enzo Ferrari on motorsport's most sacred ground. Hollywood painted heroes, but they buried the real beast in the belly of those winning cars. Forget the fairy tale. This is the story of raw American vengeance forged in the white-hot fury of a personal insult. It's the story of a secret weapon born not just to win but to annihilate. A cast-iron monster so heavy Ford's own legendary driver Ken Miles spat its nickname with contempt. The 427 side-oiler conceived not in glory, but in the bitter ashes of Enzo Ferrari's betrayal. Just 3 years earlier, Henry Ford II humiliated. He thought he'd bought Ferrari. Champagne was chilling. Then came the telegram. 427 birth and betrayal. Enzo Ferrari called Henry Ford too a fat tractor salesman. Ford's revenge plan annihilate Ferrari at Le. But Ford's engines were time bombs. At the 1964 race, every GT40 blew up by hour 9. The New York Times jeered. Ford's tractors belong in cornfields. Enter Bill Innes, Ford's quiet genius. His mission: redesign the FE block to survive 24 hours at 7,000 revolutions per minute. Working in Ford's Dearborn Skunk Works, Innes scrapped the standard top oiler design. His solution: a secret oil gallery drilled along the block's left side, feeding the crankshaft first. Mechanics dubbed it the side oiler, and it was so radical, Ford's execs nearly killed it. Why? Cost. Each block required 200+ hours of hand machining. But Innes fought back. If you want to beat Ferrari, you bleed for it. Early tests were catastrophic. At Daytona 1964, Fred Larenzin's 427 blew after 47 laps. Mechanic Herb Nab Homeman Moody recalled. Oil pressure dropped like a rock. We pulled the pan. The bearings looked like charcoal. The top oiler design starved the crank at high RPMs. Herb Nab said, bearings looked like charcoal briquettes. We found metal shavings in the pan. The crank was eating itself alive. By 1963, Ford was the auto world's titan, but their racing rep was underwhelming. Enzo Ferrari had 6 consecutive wins at Le Mans, and Ford-powered cars were coming dead last week after week. Boardroom lunches became uncomfortable as both managers and engineers scrambled for ideas to beat Ferrari. Coupled with the international humiliation Henry Ford was subjected to after Ferrari pulled out of their trade at the last minute, it was a cloudy season at Ford's plants. But that didn't last for long. Henry and his team of engineers decided to challenge Ferrari at his turf to build their credibility. The turf was Les Amas, a French endurance race known for chewing up engines, spitting out transmissions, and breaking the spirits of the world's best drivers. At that time, Ferrari owned it. They'd won it 4 years in a row while Ford hadn't even come close. So how do you take down a racing dynasty halfway across the world? You build something faster, tougher, meaner, and louder. And that's where the 427 FE side story began. Now let's get something straight. The 427 wasn't Ford's first big engine, but it was the first one built specifically to destroy a Ferrari. Back then, Ford was using a series of engines under the FE family. The 332, 352, 390 till 428. They were good street engines, solid NASCAR performers. These engines took the place of the outgoing YB block engine, which only ran for a few years after replacing the flathead V8. The FE went through different iterations and was constantly being adjusted and perfected before being replaced by the 335 series and 385 series. But LAL was a different animal. A regular V8 could hold up for a few hundred miles, maybe 500. But Leal was 3,000 miles in a single race, over 24 hours. If Ford wanted to beat Ferrari, they'd need reliability and raw power. So Ford went back to the drawing board and went to war with their own design limitations. And what they came up with wasn't just a bigger engine. It was a monster. The 427 cubic in FE was their declaration of war against Enzo 7L of raw cast-iron brutality. Though it was slightly smaller in displacement than the 428, the 427 stood tall as the true performance king of Ford's FE engine family and the only one built purely for racing. Introduced in 1963, the 427 actually displaced 425.98 cub in, but Ford rounded it up to 427 to meet the maximum engine size allowed by several racing organizations at the time. The 427's thin wall block was cast using a high nickel alloy and featured a thicker deck, allowing it to handle higher compression ratios. A short 3.784 in stroke enabled high revving performance, while its massive 4.233 in bore pushed the FE design to its limits. However, this meant the block could only be safely overboard by 0.030 in. Any more risked compromising structural integrity. To survive the brutal demands of high RPM racing above 5,000 revolutions per minute, Ford made several key upgrades. Most 427s ran solid lifters for better high RPM horsepower, while steel crankshafts replaced cast ones for added strength. Reinforced main bearing webs and cross-bolted main caps improved bottom-end durability under load. These enhancements made the 427 formidable, but still not bulletproof. When it came to withstanding the relentless abuse of NASCAR and lemon, Ford engineers realized it was time to rethink one of the engine's most vital systems, oiling. The weak link revealed itself on the racetrack. During extended runs above 6,000 revolutions per minute, the crankshaft and main bearings suffered from insufficient oil pressure, leading to catastrophic bottom-end failures. Engineers traced the issue to the oiling system. In the standard FE layout, oil was routed to the camshaft and valve train first, with the crankshaft and main bearings receiving whatever pressure remained. That sequence might have worked for street engines, but not for a race motor screaming above 6,000 revolutions per minute for hours on end. The high RPM demands of racing, where engines were pushed to their limits for hours, starved the crank of lubrication, causing bearing wear, overheating, and ultimately engine failure. This weakness threatened Ford's ambitions in motorsports, as reliability was as crucial as power in securing victories. Ford's engineers, recognizing the urgency, set out to redesign the lubrication system to prioritize the bottom end. Beyond lubrication issues, the 427 FE faced significant overheating challenges. The engine's high compression ratio and massive power output, often exceeding 500 horsepower in racing trim with high rises, generated immense heat. In NASCAR, where airspeeds on superspeedways limited cooling airflow, and in endurance racing, where sustained high RPMs were the norm, the 427's cooling systems struggled to dissipate heat effectively. The radiator and water pump designs in early 427-powered vehicles such as NASCAR stock cars and GT40 prototypes were often inadequate for racing conditions. In NASCAR, overheating led to blown head gaskets and warped cylinder heads, forcing drivers like Fred Lorenzen to retire from races they were poised to win. At Le Mans, the GT40's compact chassis constrained radiator size, exacerbating cooling issues. The 427's oil temperatures also spiked, particularly in the top oiler system, where insufficient flow to the bearings caused friction-induced heat buildup. These overheating problems compounded the lubrication failures, creating a vicious cycle of mechanical distress. The 427's prodigious torque, 480 lb-ft in street trim and higher in racing configurations, created additional challenges for drivetrain components. In NASCAR stock cars, the engine's power overwhelmed transmissions, clutches, and rear axles, leading to frequent failures. Early four-speed manual transmissions, like those used in 1963 to 64 Ford Galaxies, struggled to handle the 427's torque, with gear teeth shearing under aggressive shifts. Clutches burned out and differentials failed, particularly during restarts or when drivers powered out of corners. In the GT40, the 427's torque posed similar problems. The transaxle designed for the lighter 289 cubic inch engine in earlier GT40s was ill-equipped for the 427's output. During testing and early races,